All right, let's talk about derivations of the ideal gas law. So the first one is gas density. And you can derive the density of a gas from PV equals nRT if you remember that density is mass over volume. And when you do so we're kind of used to seeing mass in grams per milliliter. Densities of gases are given in grams per liter, and you'll see why. Now, this is an extensive property because the volume of a gas can change without changing the amount, or you can change the amount without changing the volume. So the density ends up being an extensive property for gases because it does change when you change the amount. So we'll start with PV equals nRT. Cool, got that. Then what we can do is we can realize that moles is equal to the mass divided by the molar mass, right? So mass over molar mass is grams over moles. Grams cancel and you get moles. So what we do is we take this term, mass divided by molar mass, and we substitute that in for N. And so that gives us PV equals mass times R times T divided by molar mass. Well, if we rearrange this, remembering that density is mass over volume, okay, we divide volume to this side, so we put volume down here, and we put RT down here, and we put M up here. Density is equal to pressure times the molar mass divided by R times T. So if you want to calculate the density of a mass, you can find the density given the mass. You can find the molar mass given the density. So we say, okay, what's the density of O2 at STP? All right. Well, density is pressure times molar mass divided by R times T. So we just plug those numbers in. 1 atmosphere times 32 grams per mole is the molar mass of O2 divided by 0.08206 liters atmospheres mole Kelvin times 273 K. So you'll see everything cancels, and you're left with grams over liters density. And you find that it's 1.43 grams per liter. Okay. And if you have the density, you can find the molar mass. What is the molar mass of a gas that has a density of 1.54 grams per liter at 0.86 atmospheres and 300 Kelvin? Okay. Well, if we rearrange density, molar mass is equal to density times R times T divided by P. So 1.4 grams per liter times 0.08206, okay, so liters cancels, Kelvin cancels, atmospheres cancels, and you're left with grams over moles, which is molar mass. So you find that it has a molar mass of 44 grams per mole. So it's a very simple rearrangement that allows you to solve for density. So what is the density of chlorine at 35 degrees Celsius and 675 millimeters of mercury? Well, density is pressure times molar mass divided by R times T. So the pressure is 675 divided by 760, which is 0.888 atmospheres. The molar mass of chlorine is 71 grams per mole. R is 0.08206 liters atmospheres per mole Kelvin. And temperature is 35 Celsius, so 308 Kelvin. So Kelvin cancels, moles cancel, atmospheres cancel, and you get grams over liters. And it comes out to 2.52 grams per liter. What is the molar mass of a gas that has a density of 3.41 grams per liter at STP? Okay, remembering that if density is equal to, then molar mass is equal to density times R times T divided by P. Okay, so density RT over P, so 3.41 grams per liter times R times temperature, STP, so 273, divided by pressure, 1 atmosphere. And that comes out to 76.4 grams per mole. All right, the other thing that we can do, that we can derive, is we can calculate the molar mass of a gas experimentally. So this is actually a two-step thing, but the first thing to do is to find the empirical formula. So a substance is found to be composed of 40% carbon, 6.67% hydrogen, and 53.33% oxygen. What's the empirical formula? So if you remember, you set up the percents as grams. So 40 grams of carbon, convert that to moles. 6.67 grams of hydrogen, convert that to moles. And 53.33 grams of oxygen, convert that to moles. And then you divide each one by the smallest number. We're tied, so it doesn't matter which one we pick. So divide them all by 3.33, and you get 1 carbon, 2 hydrogens, and 1 oxygen, giving us an empirical formula of CH2O. Okay. And so then you use the gas law to find the molar mass of the molecular formula. So if 0.53 grams of the substance takes up 132 milliliters of space at STP, what is the molecular formula? So remember we did that substitution. PV equals MRT over M, so M is MRT over PV, right? So 0.53 grams times R times 273 Kelvin divided by 1 atmosphere and 0.132 liters, you get grams per mole, and you find that it's 90 grams per mole. So that gives you the molar mass. And then, since I have the empirical formula and the molar mass of the molecular formula, right, I can find the molecular formula. So the empirical formula is CH2O, the molar mass is 30 grams, so molar mass of the molecular formula divided by molar mass of the empirical formula gives me N, which is 3. So the molecular formula is 3 times the empirical formula, or C3H6O3. So here's a practice problem for you. A compound is found to be 73.17% carbon, 7.32% hydrogen, and 19.51% oxygen. What is the empirical formula? So we'll start up here, and we'll do 73.17 grams of carbon, 7.32 grams of hydrogen, 19.51 grams of oxygen. And we'll convert those to moles. So for carbon, 73.17 divided by 12, and you get 6.10 moles. Then hydrogen, obviously 1, so you get 7.32 moles of hydrogen. And then 19.51 divided by 16, 1.22 moles of oxygen. So we're going to divide those all by the smallest number, 1.22, 1.22, 1.22. So we have 1 oxygen. We have 6 hydrogens. We have and we have 6.1. And we have 5 carbons. So our empirical formula is C5H6O. Cool. Next question is, if 12.07 grams of the gas are heated to 25 degrees Celsius at 1.5 atmospheres, it occupies a volume of 1,200 milliliters. What's the molecular formula? Well, if PV equals MRT over M, M equals MRT over PV. So the molar mass is equal to 12.07 grams times 0.08206 times 25 Celsius is 298 K divided by 1.2 liters and 1.5 atmospheres. Excellent. And we find, if we plug those numbers in, so 12.07 times 0.08206 times 298 divided by 1.2 times 1.5. You find that it comes out to 164 grams per mole. Okay, so let's reset our board so we can see what's going on. Okay, so we know that the empirical formula, well, we have the empirical formula here, is C5H6O, and we know that the molar mass of the molecular formula is equal to 164. So the molar mass of the empirical formula is equal to 12 times 5 plus 6 plus 16, or 82. Now you probably eyeball this, but let's go ahead and do it mathematically. So we do 164 grams per mole over 82 grams per mole, and you get 2. So the empirical formula is equal to 2 times the molecular formula. And so if we double C5H6O, we get C10H12O2.